Good morning, everybody. So sorry that this is just a little bit late today. My internet has been acting really weird at my house. So finally it's back up, and so I wanted a quick video to go with today's notes so you guys weren't lost. So I'm going to quickly go over it. We're heading into our very last thing in our unit today, and we're going to be talking about parallel and perpendicular lines. Now, we're going to be talking about parallel lines. They're going to be lines that never ever intersect, meaning they'll never cross each other's paths. They'll go on and on forever in infinite directions, and they will never cross each other. And we're going to say that we can look at this, we can look at equations, and we're going to be able to instantly tell without even using Desmos whether they're going to be parallel or not, because they have the same exact slope. If I give you two equations and they both have the same exact slope, again, I'm not worried about the y-intercept, that's not what I'm talking about. I'm talking about the same exact slope, then we would say that they are parallel lines. For example, we could do another one, y equals 3x minus 1 and y equals 3x plus 12. Those also would be parallel because we both have a 3 in the slope part, okay? So parallel lines have to have the same slope, the same exact slope. That's easy. Now we're going to get a little bit more complicated, and we're going to talk about perpendicular lines. Perpendicular lines are lines that cross, and they cross to make 90-degree angles right here. And so they intersect to make 90 degrees, and we know, without even looking at Desmos, which we're going to be using Desmos most of the time to look at, but we're going to know that they're going to be perpendicular because they're going to have something called negative, also known as opposite. Let's talk about negative and opposite. So what is the opposite of 2? Very good, it's negative 2. What is the opposite of negative 5? Very good, 2. So we're going to be talking about not 2. It would be positive 5. Sorry, it would be 5. So we're going to be talking about the negative and the opposite of a number, and we're also going to be talking about the reciprocal. It has to have two conditions. So not only are we talking about the opposite, 2 and negative 2, we're also going to be talking about the reciprocal. So 2 and 1/2. 2 and 1/2. And see, what's the opposite of 1/3 would be 3. So we're going to be looking at both of those. But it's got to have both opposite and reciprocal slopes. So for instance, let's look at our example. First off, what's the opposite of a positive 2? It would be a negative 2. So first off, my answer's got to be negative. From there, we got to take the reciprocal. And the reciprocal of 2 is 1/2. 1/2. 1/2. So here would be my answer. And we would be able to look at these and say these are perpendicular lines. We also have another one, y equals, let's try 1/3 plus 1. So this one would be first thing, I forgot the x. So the reciprocal first will be 3. And then, since this is a positive, it would have to be a negative. So it would be y equals 3x plus 12. And again, y-intercepts don't matter. They could be different. We're just looking at the slopes. So let's just practice some reciprocals for a little bit. What it would be the negative reciprocal of 3/4. And remember, we're not just talking about negative, we're also talking about the opposite. So really this should be called the opposite reciprocal, but they call it negative. So first off, what is the opposite of a positive? It's going to be a negative, right? So let's get that there. And then what's the reciprocal of 4/3 or 3/4? Well, it would be 4/3. Number 2, what is the opposite of a positive 2? It would be a negative, right? If I have a positive, then I'm going to have a negative. That's its opposite. And then what's the reciprocal of 2/1? Well, it would be 1/2. Over here, what's the opposite of a negative? Well, it would be positive, so my answer is going to be positive. And then I'm going to take the reciprocal of 7/8, and it would be 8/7. And a positive 8/7, because I have a negative. And so over here, what's the opposite of a positive? Well, it would be negative. And then 1 would just be this. We could say this is 1/1, so this would be negative 1/1, and it would still just be negative 1. So the opposite reciprocal of 1 is just negative 1. And then what's the opposite reciprocal of 0? This is a trick question. What's an opposite of a line that goes like this? A line that goes like that. And what kind of line is that? That is an undefined line. So the opposite reciprocal of 0 is undefined. So let's look at some of these. So we are going to be finding the slope and then deciding whether it is parallel, perpendicular, or neither. First example I'm going to do with you, we're going to use slope formula. And then after that, we're going to use Desmos. So slope formula, remember and I think I attached it up here. We just can't see it on my thing. I attached the formula above if you need it. So it's going to be y2 minus y1, so 6 minus 3. And then it's going to be 2 minus a negative 2, which really becomes a plus 2. So from here, we're just going to do simple math. 6 minus 3 is 3, and 2 plus 2 is 4. Now we're going to find, it wants us to know if these two lines are parallel. So now we're going to say 3 minus 0, and 3 minus 0 is 3. And then we're also going to do a 3 minus a negative 1. 3 minus a negative 1 becomes a 3 plus 1, and we have a fourth. So let's look over here. I have a 3/4 and a 3/4. So if I have the same exact slope, what kind of lines am I going to have? Very good. I'm going to have parallel. Remember, those are parallel lines. So you're just going to drag this little piece over. I'm just going to have to do this for right now because it's being silly. But you would just drag your little piece over like that. So it would be a parallel line. Let's try this one. So the next one we're going to do 4 minus 2. 4 minus 2, which obviously is 2. And then 5 minus 0. 5 minus 0 is 5. So we have 2/5. Here we have 3 minus 8. 3 minus 8 is a negative 5. And then we have a 3 minus 1. 3 minus 1 is a 2. So let's look. First off, I have a positive and then I have a negative. So that's the opposite. And then I also have a reciprocal, 2/5 and 5/2. So those are opposite reciprocals. And when I have an opposite reciprocal, what kind of line do I have? Very good. I don't know why it's not letting me move it, but that's okay. I'm just going to drag it. All right, so I have a perpendicular line. Very good. Very, very good. Okay. So that's how, if I give you two lines like that and ask for the slope and I give you 2 points, that's all you're going to do is find the slope and then go from there. So we're going to do the same exact thing, but we're going to try it in Desmos. So we're going to do 6 minus, I'm putting these in Desmos. Here we go. So parentheses 6, parentheses 6, comma 8, close parentheses, and then parentheses -1, comma 8, and make sure those match. Nope, they do not. I don't know what I was looking at. I need 2 and 6 up here. Sorry, I'm just putting in these two. So let me try that again. So -1, 8, 2, 6. Okay, so here's my 2 points. I am going to find the slope here. So it looks like I'm going down, so it's negative. And I'm going down 2 over 1, 2, 3. Again, I can take a screenshot so you guys can see what I'm looking at. So here's the slope. So I go down 2, over 3. So my slope is -2 over 3. So my slope is -2 over 3, so we're going to put that in. -2 over 3. And then we're going to try this one, and this one's going to put those in parentheses. We're going to do -1, 2, and then we're going to do 3, 3. And this looks like a positive slope. So this is a positive slope, and let me take a screenshot real fast so we can find the slope. And it looks like I am going up 1, over 1, 2, 3, 4. So up 1 over 4. And I'm going to make sure I have the right points in. Yep, up 1 over 4. And so let's look at those slopes. Are they the same? No. So definitely not parallel. Are they reciprocals? are they reciprocals to each other? Meaning negative reciprocals. So really I would need a positive 3 over 2. And they are not. So this is in a case where we would just say, hey, they're neither. They're none of the above. They're just neither. They're just 2 random slopes and 2 lines that we are looking at. So we would drag this over and we would say, they're neither. All right, let's try one more. Let's try comma 2, 3. And let's try negative 1, comma 4. So here's my 2 slopes. I'm going to take a screenshot so we can find them. So it looks like I'm going down 1, down negative 1, over 1, 2, 3, positive 3. So negative 1/3. So this is going to be negative. This slope was negative 1/3. And then we're going to find the next one, which would be comma 5, 3. Oop, that's a negative 5. We got to make sure that's in. And then we also have a negative 4, 6. There we go. And let's look at this slope. This one's positive, we can tell from left to right, and it looks like I'm going up 4 over 1. So I have 4 over 1, which is just 4. So I have 4 over 1. I think I meant to put a 4. Let's go back to this one real quick. So I think I did it wrong. So 4 over 1. Let's go back to this slope one more time. So it would be comma 2, 3, and negative 1, 4. And so I think this one says, so this one's down 1 over 1, 2, 3. Yeah. So negative 1/3. So those 2, even though they are so, I'm going to check the other one because they seem so close, but I don't think they are. I don't think they match because one's a 1/3 and one's a 1/4. So I don't think they match. But let's try it one more time. Those are a little too close for comfort, so it's always good to check. Let's see, there we go. Yep, see, I counted wrong. I knew I did one of these wrong. It's always good to go back and check because to me that was almost a opposite reciprocal, and I wanted to make sure I had the points in right. 1, 2, 3, and now I do. So it's actually positive 3 over 1. I counted 4 by accident. So this is positive 3 over 1. Now, it was too close for comfort, and I'm glad I rechecked it. Because now, before with the 4 there, those were neither. Now, this is a perpendicular line because I have a opposite reciprocal of my slopes. Pull that down. Sorry, for some reason they're not wanting to drag, so we're just going to do it just like this. Okay, so that's how you would do it by hand. Now we're going to learn how to do it, how we're really going to do it, and we're going to do it with Desmos. And we're going to look at our lines. I'm going to give you 2, I'm going to do the first 2 examples with you. We're going to put the equations in exactly the way we see it. Y equals 7x plus 2. And we also have y equals 7x minus 1. Okay, let's look at those. And I can zoom in. What kind of lines are those? When I put both of those equations in, and I'm looking, what kind of lines are those? If you're saying parallel, you are 100% right. So we're going to drag this in. Those are parallel lines. They're also parallel lines if we didn't want to use Desmos real fast because they're in y-intercept. They both have the same slope, and we know same slopes are parallel lines. Here, obviously, we're going to look at their slopes, and we have negative reciprocals, and we know that negative reciprocals are what kind of line, but say you forgot about that. You can put these into Desmos exactly the way you see them. Oops, move that out. X minus 8, okay, and then we have y equals negative 5 fourths x plus 3. Okay, let's look at these lines. Yes, those are perfect. And you got to be careful. You got to really make sure that they're perpendicular, meaning 90 degrees, and you're going to be able to tell. And they are. They're perfect 90-degree angles. So yes, these would be perpendicular lines. And so you can use Desmos to your advantage as well to help you with the lines. But say Let's do one more where I'm giving you an equation that is actually in y-intercept. Let's look at these. These are almost opposite perpendicular, except this one's not flipped. It would need to be 3/1. And so we would probably say that these are neither, but let's double, triple check in Desmos. So y equals -1/3 x plus 2. That's not right. Move that over. X plus 2. And then we would just say y is equal to 1/3 x. Just like that. Okay. And let's look. No, those are not perpendicular. Those do cross, whatever, but they are definitely not perpendicular. Those look like they have acute, if you remember that term, obtuse, and acute angles. They're definitely not 90 degrees, so this would just be neither. So let's drag this neither sign over, and one more. You're going to see that 9 times out of 10, we're going to give you equations, that are not in y-intercept form. So this is going to be very hard to look at and determine whether the slope is the same or whether it's an opposite reciprocal. So, thank goodness for Desmos, you're just going to put it in exactly the way you see, and you're going to examine the lines on Desmos. 3y equals 18x minus 6, okay? And when I put that in, what kind of lines do I have? I put them in exactly the way I see. We can't really tell the slopes because they're in standard form. But what I can look at is on my graph. And on my graph, I immediately see that they make what kind of angles? Yes, 90-degree angles. And so those are perpendicular lines. Very, very good. So let's drag that over. Perpendicular lines. So there's our answers. One was parallel with the same slope. These two were perpendicular. And then this one was neither. So what you're going to do, this is easy peasy practice. Obviously, we have parallel, perpendicular, and neither. And I've given you examples for both. And so what you're going to do is put these equations in one at a time into Desmos. So 3, and some of them are already in forms that you can look at. If you don't want to use Desmos, just be very careful. Like this one's tricky. It gives you a decimal and it gives you a fraction. Be very careful with that. When in doubt, always use Desmos and really see if the lines are crossing or not. So 3x minus 4y equals 3. And then I'm going to put the second equation in at x plus 6y equals 3. And I'm going to look at my line, and I have a perpendicular line. So these 2 points right here, I would move over to my perpendicular. And you would go to number 2, and you would put these in. And it would be 3x minus 2y equals 9. And then 2x plus 3y equals 9. And again, those two lines make perfect perpendicular lines. So you would drag that over there. So that's all you're doing, is you're checking them and seeing what kind of lines. And sometimes they'll be neither. Sometimes those two lines cross with crazy angles, and they're neither parallel nor perpendicular. They're just neither. Be careful when you get to here. You have to find the two slopes and tell me whether or not they're perpendicular or there. So you're more than welcome to put the slopes into Desmos or find them with their formula. But these two are your challenge, so be very careful with these and really try to get these two answers. So if you need anything, let me know. Again, I'm sorry it was late. My internet all weekend has been off. It went out on Friday, so it is back up. It was running. Luckily, I was able to make slides. I just wasn't able to record and put anything on Canvas. So we're on to go, and let me know if you need anything today.